This module will show you how to complete the Kruskal-Wallis Test. The Kruskal-Wallis Test is a non-parametric alternative to the one-way ANOVA. It compares differences between several independent groups and presents pairwise comparisons for individual group differences. Statistically, it ranks the scores, then sums group ranks. To begin, we must check the dependent continuous variable for normality. In this case, it is sperm. To do this, we go up to Analyze, Descriptive, Explore. We move sperm across to the dependent list. Under Plots, we select No Box Plots, Normality Plots with Tests, deselect Stem and Leaf and select Histogram and click Continue. We then select OK. As you can see, there is 80 cases in our sample and we don't have any missing variables. When we have a look at our descriptives, the mean, there is 3.83 million for the sperm count on average, ranging from 0.31 up to 21. Our skewness and kurtosis is quite great, and we know this because it's quite far away from the value of 1. In our tests of normality table, we want to have a look at the Shapiro-Wilk statistic. And given our p-value is 0.000, this is less than 0.05, and therefore we know that sperm count is not normally distributed, and therefore we can continue with the non-parametric alternative, the Kruskal-Wallis test. We can scroll down and check our histogram, and we can see that it's definitely not showing a bell-shaped curve. And when you have a look at your QQ plot, there's a lot of points that are not sitting along that line. This confirms visually that sperm count is not normally distributed. In this worked example, we want to know, is there a difference between the number of soya meals per week and sperm count? If you have a look at your data view, you can see that soya is a categorical variable. And if we have a look under variable view, you can either select and look at the values, or under data view, you can select the change of the value labels. And we can see that 1 is no soya meals. We then have 1 soya meal per week, 4 soya meals per week, 7 soya meals per week. To see if there's a difference in sperm count based on the number of soya meals consumed per week, we're going to perform the Kruskal-Wallis test. We come up to Analyze, Non-Parametric Tests, and then we come to Independent Samples. You'll see that the default is to automatically compare distributions across groups. However, we want to come to Customize Analysis. We then come across to Fields, and you can see that if you use predefined roles, it automatically puts your variables in. However, if you click Use Custom Field Assignments, we just need to move our sperm count across to our test fields. That's our continuous variable, and our number of soya meals per week into our groups. We then come across to the Custom Settings tab, and we select Customize Tests, and we're going to choose the Kruskal-Wallis one-way ANOVA. We have an option for multiple comparisons, and we're going to keep this as all pairwise. Now select Run, and you'll be able to see that the non-parametric test output comes out. Under your hypothesis test summary, we're wanting to look at SIG and the decision. So as your p-value is 0.034, this is less than 0.05. So we know that there is a significant difference in sperm count between the different soya consumption groups. And the decision guides you, telling you to reject the null hypothesis. When we scroll down to the test summary table, the information that we'll be using in our write-up includes total N, so this is your sample size, which is 80, our test statistic of 8.659, our degrees of freedom, which is 3, and our p-value, which is 0.034. The box plot figure displays the distribution sperm count between the 4 different soya meal groups. You can note the outliers at the top. The median score is similar across 3 of the soya meal groups and is slightly lower for 7 soya meals. While the hypothesis summary table informed if overall there was a significant difference, we now review the pairwise comparisons which tell us between which groups the differences lie. Note, it is possible to have a significant Kruskal-Wallis test but not have significant pairwise comparisons. To do this, we review the SIG column on the far right. This provides your p-value adjusted for the fact that multiple pairwise tests have been completed. If p is less than 0.05, you have a significant pairwise comparison. In other words, the distribution of the 2 groups are different. In this case, all of the p-values are greater than 0.05, and therefore there is not a significant pairwise comparison, and the distribution of the 2 groups are similar. For reporting, we need to report the median value for sperm count per each different soya meal per week consumed. As this isn't provided in your output, you need to formulate this separately. To do this, we come up to Analyze, Compare Means, and come across to Means. We move sperm count across into your dependent list, and your categorical variable or your independent variable, in this case soya meals, is moved into your independent list. Under Options, we've currently got on the right-hand side mean, number of cases, and standard deviation, and we want median. So left-click on median and bring that across as well. Click Continue, then click OK. As you can see by the case processing summary, you have a sample size of 80 with 0 cases missing or excluded. Down the bottom, you can see the report, which provides you not only the sample size per category, but also the mean, standard deviation, and median values for sperm count per number of soya meals per week consumed. When you're visually looking at this, you can see that when no soya meals are consumed, there's a higher sperm count of 3 million compared to 1 soya meal, 4 soya meals, or 7 soya meals per week. To report your findings, you'll need to draw information from this median table, as well as from the test summary or the hypothesis test summary table. You may report something along the lines of that there was a significant group difference in sperm count reported in millions based on the number of soya meals consumed per week. Participants who consumed no soya meals per week had a greater median sperm count than participants who consumed 4, 1, or 7 meals. A pairwise comparisons with a Bonferroni correction for multiple comparisons was performed to assess between group differences. However, this post hoc indicated no statistically significant difference in sperm count between any of the soya meal consumption group combinations. If you're using hypotheses in your write-up, in this example, as the p-value was less than 0.05, you would state that you have evidence supporting the alternative hypothesis.